All right, let's dive right into this explainer. Today, we're breaking down the exact anatomy of how to systematically spot, assess, and completely neutralize workplace hazards using proven safety protocols. Look, whether you're stepping onto a massive, bustling construction site or just analyzing the everyday framework of your own workspace, really understanding the true life cycle of a hazard is absolutely critical. We're going to map out the entire journey of a threat, literally from the exact second it pops up to the precise steps you need to wipe it out entirely.
Here is how we're breaking it all down today. 1. Identifying hidden hazards. 2. How to assess risk. 3. The hierarchy of controls. And 4. Safe practices versus procedures.
Okay, Section 1, Identifying Hidden Hazards. Let's talk about the actual threats lurking out there.
We generally chop these hidden dangers into 4 distinct categories. First up, chemical risks. Now, these can have acute effects that hit you immediately, like a chemical burn, or chronic effects from long-term exposure. Then you've got physical threats, which are environmental conditions that threaten your physical safety. So think extreme temperatures, vibration, or really intense noise. Next are biological dangers, living things that can harm you, like mold, fungus, or airborne pathogens. And finally, ergonomic hazards. These are the sneaky ones that cause musculoskeletal injuries from poor workstation setup, repetitive movements, or heavy lifting.
Now, this is where it gets really fascinating, a concept called hazard stacking. You see, sometimes a single hazard doesn't actually pose a major risk to your safety on its own, but when it combines with others, the risk level absolutely skyrockets. Think about noise for a second. The sound of a single hammer might be perfectly safe for your hearing, but when you stack that with the noise of saws, nail guns, and heavy machinery all running on the same site, that combined noise suddenly reaches a highly hazardous level. It's like a giant puzzle where the pieces multiply the danger.
Let me put this into perspective because this brilliantly illustrates the extreme physical danger of hazard stacking. Consider standard sheets of drywall. One sheet, not much of a hazard. But if you have 10 sheets stacked together, leaning against a wall, their combined weight is roughly 450 kilos. Now, if those stacked sheets tip over, by the time they reach a falling worker, the stopping force hits a massive 2,700 kilos due to momentum. That is an enormous jump in force. I mean, that is easily enough to crush an arm, a leg, or even a skull.
That crazy high-stakes math is exactly why simple interventions are a total game changer. To prevent this deadly stacking hazard, sheet materials must always be laid flat on the ground. Just take gravity out of the equation. If there simply isn't enough room and they absolutely have to be stood up, you've got to use a secure tieback system so they physically cannot fall. It's a remarkably simple step, but it completely neutralizes a 2,700-kilo threat. Moving right along to Section 2, Assessing Risk, let's look at how we measure the danger. Before you even think about starting a task, it's standard practice to conduct a daily field-level hazard assessment. You'll sometimes hear this called an FLHA or FLRA. You do this right at the work area by following 4 strict steps. 1. Identify each step of the job. 2. Document the specific hazards involved in those steps. 3. Assess every single hazard you just found. And 4. Assign controls to actually manage them. Listen, missing just one hazard in Step 2 compromises the entire system, right? Because obviously, you can't manage a danger if you haven't identified it in the first place.
When you hit Step 3, assessing that hazard, you basically have to weigh 2 specific factors against each other to prioritize the danger. We look at probability, what is the actual likelihood of someone being exposed to this hazard, and we weigh it against severity. If it does happen, how bad is the outcome or injury going to be? Fixing the hazards that score the absolute highest in both probability and severity becomes your immediate priority, and crucially, this whole assessment happens before any safety controls are actually put into place.
All right, Section 3, the hierarchy of controls. Time to neutralize those threats.
So, to actually neutralize threats, we apply what's known as the hierarchy of controls. This is a priority system for minimizing risks. We always start at the top with the most effective strategy at Step 1, and we only move down the list toward the least effective strategy at Step 5 if those higher options are completely impossible. Let's break down exactly what each of these tiers actually looks like in practice.
The absolute best option, hands down, is always elimination. It sits right at the top of the hierarchy because it completely removes the source of potential damage. Think about it. Working at heights is inherently dangerous. Even with top-tier safety gear, a fall can still happen. But if a window cleaner uses a specially designed long brush that lets them wash the windows while standing firmly on the ground, well, the hazard of falling from a height is completely eliminated.
Now, if completely eliminating the hazard just isn't an option, we move down to Step 2,
substitution. This literally means replacing the hazard with something safer, like swapping out a highly toxic solvent-based paint for a much safer water-based alternative. If that's a no-go, we move to step 3, engineering controls. These are actual physical changes to the environment designed to physically separate people from the danger. We're talking about things like installing guardrails along a roof edge, dropping trench boxes inside an excavation site, or adding heavy-duty ventilation systems.
So that brings us to the bottom 2 tiers, and these are the least effective because they rely entirely on human compliance. Step 4 is administrative controls. This means changing how people work through rules, training, or worker rotation, like limiting exactly how long one person is allowed to operate a heavy, vibrating jackhammer. Finally, at the absolute bottom is PPE, or personal protective equipment. PPE is the least effective because it doesn't manage the hazard itself. A hard hat or safety glasses only reduce the severity of an injury upon direct contact, and that is exactly why PPE is meant to be used in combination with higher-level controls, never as your only line of defense. Which brings us to Section 4, Safe Practices versus Procedures, Workplace Rules on a Daily Basis.
People mix these two terms up all the time, but the distinction is incredibly important. A practice is a set of ongoing guidelines, do's and don'ts that aren't in a specific order. For example, wearing a seatbelt and never texting while driving are safe work practices. You just do them the entire time you're doing the task. A procedure, on the other hand, is a strict, written, step-by-step instruction on how to complete a high-risk task. In a procedure, the order matters completely. In fact, listen to this. If followed perfectly as written, a solid procedure is designed to prevent 100% of accidents for that specific task. Why? Because a verified procedure accounts for every single assessed variable and completely removes human unpredictability from the equation.
A perfect example of a procedure is setting up an extension ladder. You can't just casually throw it against a wall and hope for the best. The mathematics here are actually incredibly precise. The written procedure dictates you must first secure it on a firm, level surface. Then you place it so the horizontal distance from the wall is exactly 1/4 the ladder's length, which gives you a perfect 75-degree angle. Next, you ensure the ladder extends a minimum of 1 meter above the landing platform. And finally, as you climb, you maintain 3-point contact at all times, meaning 2 feet and 1 hand or 2 hands and 1 foot are always firmly on the ladder.
And the reason safety managers are so obsessed with procedures is that they literally leave no room for guesswork. If a procedure is executed out of order, you aren't just failing to be safe. You are actively introducing brand new, unidentified hazards into the environment. Think about it. If a step in that ladder procedure is skipped, the ladder might slide, creating a new falling hazard that the initial risk assessment never even accounted for. This is exactly why strictly following a verified procedure guarantees safety and prevents 100% of accidents, while deviating from it pretty much guarantees risk. So, look around your own workplace today and ask yourself this final question. Are you systematically eliminating hazards using the correct hierarchy of controls and rigorously following procedures? Or are you just slapping on some PPE, letting hidden dangers stack up and kinda hoping for the best? Understanding the life cycle of a hazard is just the first step. Taking the exact correct action is what actually keeps things running smoothly and gets everyone home safe. Thanks for joining me on this explainer. It's a really great reminder to view our own daily routines through this exact lens. Stay safe out there.